Hi, Assalamualaikum. Welcome back to my session revision on trial paper. So today we discuss trial SM Pahang paper 2. Okay, so for tonight I will discuss on section A. 60 marks. Look at number 1. Okay, diagram 1 shows the black body radiation. I hope you remember the definition for black body. So this black body we discuss on the topic of quantum physics. Okay, the first part is 7.1. So discuss about black body. So black body is an idealized body that can emit or absorb or range of electromagnetic radiation. Okay. So if you remember, we have this graph. Intensity against wavelength. Okay, intensity against wavelength. Okay, longer wavelength. This one, infrared. Okay, means the black body can emit this range of radiation. So you can observe by using a special camera to observe the infrared that emitted. And then we have X here, the visible light range. Visible light range, we have orange, green, blue, and violet. Okay, this is a color. Okay, but according to the wavelength, it should arrange like this. Okay, not this way. Because here is longer wavelength. So it should be here red, orange, yellow, green, blue, indigo, violet. And then we have ultraviolet here. Okay, so this is visible light. Then after that is ultraviolet. Okay, so this is what discussed by quantum physics, which again what discussed by classical physics. At high frequency, the intensity should increase according to classical physics, but based on what found by the quantum physics, at a very high frequency, the ultraviolet, suddenly the intensity of light drops. Okay, so this one we call it UV catastrophe. Okay, so I hope you know that because you have studied this one in quantum physics. Okay, look at A. Okay, what black bodies are the ideal what of electromagnetic radiation. Jasa hitam, apa yang unggul? Actually, it is a perfect or ideal absorbers and emitter or radiator at the same time. Okay, so you cannot just stick for absorbers or radiators, but you must stick for this one. Okay. Dia adalah kedua-dua penyerap dan pemancar emitter. Term lain kita boleh guna ialah emitter. Okay, B, based on the diagram 1, name the radiation in box X. That one we call it visible light. Okay. If you remember the electromagnetic wave spectrum, you will know after ultraviolet is visible light ataupun cahaya nampak. Mata boleh nampak lah cahaya tu. Warna tu boleh nampak oleh mata. Yeah, that's why we call it visible light. C1, experimental results involving black body radiation are inconsistent with classical physics theory. Okay, based on diagram 1, what was the controversy that sparked the theory of quantum physics? Okay, So actually based on the classical, as we discussed before from here, very short wavelength means the highest frequency. As frequency increases, according to classical theory, the graph should increase like this. So this is what classical theory mentioned. But it became controversy when found by the quantum physics at a very high frequency. For example, frequency is ultraviolet, suddenly the graph drops or intensity becomes smaller. So that one is the controversy that we call UV catastrophe. Yeah? Malapetaka ultraviolet. Okay, ultra ungu, malapetaka ultra ungu. Okay, so what happened is the intensity, keamatan cahaya, intensity of radiation on the left side, meaning the ultraviolet side, the left side of the graph. Okay, left side of the peak. The peak there is the the visible light now. Does not continue to increase. Okay, on the left side peak does not continue to increase means at the high frequency one, okay, the intensity of light drop. Okay, so this one is the what is against the classical theory. Okay, side of peak means at high frequency, does not continue to increase. Okay. So what did Max Planck propose to solve problem in C1? Okay, so to explain this, why suddenly the intensity of light drop on the left side of the graph? Okay, the Max Planck, okay, give uh, explanation on this, stating that the energy of electromagnetic wave or energy of photons or light is in form of discrete, not continuous, as suggested by classical theory. Okay, the energy this depends on the frequency of okay, so the graph does not follow what is stated by the classical theory. Okay, so it shows the shape like a statistic distribution. Okay, So you can read more if you are interested on this about Wien's law and then about the Maxwell-Boltzmann distribution, okay, equation. So that one will explain why the shape of craft is become like that. Okay, that one, what is stated by Max Planck, energy is in discrete form or travel in quanta. Okay, so we call it photons. Okay. Okay, diagram 2. Number 2. Diagram 2 shows a large pot noodle being cooked in large amount of hot water. So if you look at the diagram, you can understand this is about heat energy topic, heat topic. So what is the meaning of heat? Apakah yang dimaksudkan dengan heat? Heat is a form of energy that can be transferred. Okay, heat is a form of energy. Okay. One mark only. If 2 marks, you need to elaborate more. This one enough already. Heat is a form of energy. Okay. Why is the noodle being cooked in large amount of hot water? We want to cook the noodle faster, so it requires more heat energy. So we use the concept of heat capacity here. 2 marks. Large amount of water contains larger. Okay, dia mengandungi jumlah tenaga haba yang besar. Contains larger heat capacity. Konsep muatan haba. Large amount of water contains larger heat capacity. Thus, large amount of heat is transferred to noodle. To the noodle. Okay. So the noodle can be cooked, okay, when using large amount of hot water. Okay. Okay, B, 2 kilogram of water at 30 degrees Celsius added to 9 kg of hot water, 95 degrees Celsius. What is final temperature of mixture? Okay. So we have 2 kg of water. Nine kg of hot water. It's the same 9 kilograms here. Okay, so we have one more 9 kg. Just mix it. Okay. So it becomes mixture. Okay, this put as mixture. The final temperature, let's assume as theta. For 2 kg, we can put as M1, and initial temperature we can put as theta 1, which is 30 degrees Celsius. 9 kg M2, the temperature we can put as theta 2, 95. Okay, both water, so same specific heat capacity here, C, 4200. Okay. Okay. So now this one is cold, this is hot. So what happened is the cold one, oh sorry, the hot one will release heat, the cold one will absorb heat. Okay, before thermal equilibrium is achieved, the hot one will transfer heat at faster rate, and then this one will absorb heat, Q. Okay. Okay. Assume there's no heat loss surrounding, meaning heat released by M2 is equals to heat absorbed by M1. Or we can say Q1 equals to Q2. Okay, the heat absorbed causes change in temperature. So formula is M1 C1 theta. Okay, change in temperature will be for theta 1. This one absorb heat initial 30. So the final temperature is larger than 30. So it becomes theta minus theta 1. Because this one cold. And then Q2, hot object, it release heat. So the temperature theta, the final temperature is smaller than 95. Okay, so M2, C2, okay, theta minus, it should be theta, okay, theta 2 minus theta. Okay. C1 equals to C2 because both are water, so we can cancel this one. Substitute M in kilogram, 2 theta minus 30 equals to 995 minus theta. Okay, so you solve this one mathematically, you will get the answer. Okay, theta equals to 83.18 degrees Celsius. At least 3 significant figures. Okay, so I want to show it faster, so I didn't show the step. So I just jump to here. So you can try yourself how to solve this because this one is only the mathematical operation. Okay, jadi kena faham konsep thermal equilibrium nak jawab soalan ni. Okay. Okay, number 3, in a crash test, a car of mass 1500 and speed 100 collide with a wall as shown in diagram 3. Okay, case pelanggaran pula. Kalau tajuk pelanggaran ni dalam topik apa? Momentum. Principle of conservation momentum, prinsip keabadian tenaga. Okay, so we have two situation here. Okay, before, after. So initial velocity, jawab. Final velocity is 0. Okay, stop. So what is the meaning of impulsive force? Okay, so impulsive force is a force that acts during collision. So you can write down as the rate of change of momentum during collision. Okay, impulsive force F and V minus U divided by T. Change in momentum divided by T. So it becomes rate of change of momentum during collision. So we call it impulsive force. Explain how the crumple zone reduces the impact. Crumple zone is like a soft surface. It's not really soft, but it can crumple. So when it crumple, the car does not stop suddenly. Yeah, it will take time to become zero, the velocity. So it means it lengthens the time of impact. Okay, so the crumple zone will cause the time of impact to increase. Okay, thus impulsive force decrease. Okay, sudah remote sudah remote. The crumple zone lengthen, memanjangkan masa pelanggaran. Lengthen the time of impact and reduce impulsive force on the car. Okay. The crumple zone lengthen the time of impact and reduce impulsive force on the car. As a relationship, F equals to M E minus U divided by T. Okay. So this one is impulsive force, this is time of impact. So you can see the inversely proportional relationship. So when time of impact is increases or lengthen, impulsive force decrease. Okay. If the car in diagram 3 stop in 15 seconds, calculate impulsive force acting on the car. So F equals to M P minus U divided by T. Okay, now if you look at the value given here, 100 kilometer per hour. Impulsive force you want to state in Newton, which is SI unit. Thus, the velocity here, initial velocity, 100 kilometer per hour. You need to convert to meter per second. 100 times to the power 3 meter divided by 3,600 seconds. Okay, so you will get the answer equals to 27.78 meter second. Okay, then only you substitute here mass of the car equals to mass 1,500 kilogram, 1,500 kilogram. Final velocity 0 minus 27.78. Divide by 15 seconds. Answer is negative 2.778 meter. Okay, answer is correct. With Newton unit. Okay. Impulsive force on the car is on the right side. On the car. This is on the wall. Okay. So action force is Fw. The on the car is reaction. Okay. So you will get the value is negative here. Okay. Action force is to the left. Reaction is to the right. Means on the car is right side, so we get negative value. Okay, number 4, diagram 4 shows a few man-made satellites from various countries. What is meant by geostationary satellite? Okay, the word geostationary means it fixed at one location, at the orbit of the Earth. It always stay at the same location, okay, at the orbit. When orbiting the Earth is above the same location, the geostationary satellite, because its period of rotation also same as Earth. Okay, a satellite which is orbiting the Earth and always and stay at same geographical location. Okay. For example, this one is Earth, and there is a satellite here orbiting. Okay, the Earth has a period of rotation 24 hours. So this one also 24 hours rotates. So meaning it will stay at the same location. Let's say location A, there is a satellite. Because of same period of rotation, so the satellite will stay at the same geographical location. So that's why we call it geostationary satellite. Okay. That's a special orbit for this satellite to orbit the Earth. Okay, there are two characteristics. You can state two characteristics. First one, you can state as something, okay, rotates in same direction as Earth rotation. Dia rotate direction yang sama. Second, okay, rotate with same period of rotation. Rotation. as period of the Earth. Rotation. Okay, or we can say is 24 hours. Okay, there are more than two, you can state two only. So we have other than that something like always stay at the same geographical locations. So I mentioned already above here. Okay, same direction, same period. Very simple to memorize. Okay, see geographical satellite mass 1200 kg placed at this one from center. So this is R M. Okay, calculate linear speed of satellite. Okay, formula for linear speed. What is a formula? If you forget the formula, you can use again, derive the formula. mv squared over r equals to g over r squared. You can cancel this one r here cancel, one. So you have v squared equals to gm over r. So the linear speed v equals to square root of gm over. Okay. So linear speed of the satellite orbiting the Earth. So m here is mass of the Earth and r is radius of orbit. Okay. So v equals to square root of gm over r. Substitute all the values. G 6.67 times 10 to the power of negative 11. Mass of Earth 5.97 times 10 to the power 24. Okay. Divide by R. R is 4.23 10 to the power 7. Okay. Okay. Use calculator to calculate. Okay, so you will get the answer V equals to 3.07 10 power 3 meter second negative. Okay. Part 2. Okay, Earth's gravitational pull on the satellite. So when a satellite orbiting the Earth, there's also centripetal force act. The centripetal force act equals to gravitational force. So you can calculate using the formula F equals to GMM over R squared if you have mass of satellite. But now for this question, I think we don't have, oh, there is a mass given here, 1200. Okay, okay. So you can use this formula, F equals to GMM divided by R, or you can just use the formula F equals to mv squared divided by R. Both can be accepted. Okay, should get the same value. Okay, let's say I use this one, simple, a bit simple lah dia punya value dia. So F equals to mv squared over R. So 1200, 3.07 10 power 3 squared divided by R. Okay, so you get the answer. Calculate. 267.37 U. Okay, so this is the gravitational force, okay, act on the satellite. Okay, D, what happens to the satellite if the speed is lower than the orbital speed? Okay, so normally at certain orbits, the satellite will orbit with certain orbital speed. So if suddenly the speed of the satellite drop or lower, what happened to the satellite? Satellite cannot stay there already. So it will drop to a lower orbit. Okay? Okay, if the speed keep to decrease and decrease, it will continue to drop and maybe finally it will enter the atmosphere of the Earth, and then due to the air resistance, it will cause it to burn. Okay, because of high temperature. Okay, as we know, the speed is very, very large. So when enter the atmospheric pressure, travel at very high speed will cause very high resistance. High resistance will increase the temperature of the satellite and causes it to burn. Okay, the satellite will drop to low orbit or enter the atmospheric layer air resistance will produce large amount of heat that causes it to burn. Okay, satellite drop to low orbit or enter the atmospheric layer. Air resistance will produce large heat that causes it to burn. Okay, as we know, friction also will cause heat to be produced. So in this case, is air resistance. Okay, number 5. Diagram 5.1 and 5.2 show identical copper rod placed on bare copper wire in a magnetic field. When the switch is closed, pointer of emitter deflects and copper rod moves to the final position. Okay, look at the diagram. We have emitter to detect current. So the copper rod here, initial position, this is the final position. When the switch is closed, you can see the copper rod will be moved. Okay, let's say distance here, one. Okay, one. So this one shows that when current flow through the copper rod, it will produce force that cause it to move or displace. Okay, apa yang menyebabkan dia bergerak? Ada force dihasilkan. Okay, so this one is case what? Force on current carrying conductor in magnetic. Okay, when current flow through the rod, it becomes current carrying conductor. When the current pass through current carrying conductor, it produces magnetic field around the conductor. Magnetic field of permanent magnet and magnetic field of the rod interact, produce catapult field, non-uniform field. The non-uniform field produces net force on the copper rod, forces it to move. So force on concept, force on current carrying conductor in magnetic field. Very long name of concept. Okay, so this is the concept. Right. Same thing here. You can see this one, the second one. Okay, the difference between these two, you can see a number of dry cell, and then the distance of the copper rod move D2 is longer. Diffraction of the emitter also is larger. What is the meaning of magnetic field? When we talk about field, it refers to a certain region. So we can use the word a region where magnetic substance or ferromagnetic material experiences magnetic force. Okay, for example, you have a magnet, like this one magnet, north, south, and then you bring, for example, a paper clip. Paper clip is ferromagnetic material. If you put far, this one cannot attracted to the magnet. But if you put closer, it will be attracted. So means if you put closer and attracted, means you place this one, the pin, the pepper pin or paper clip in the region that we call magnetic field, meaning the pin experience magnetic force. Okay, so normally the region is closer to the magnet. It is stronger close to magnet. If far, it becomes very weak. Okay, that one is magnetic field. Observe diagram compare number of dry cell. Okay, number of dry cell bilangan battery in 5.1 is smaller ataupun lower pun boleh than 5.2. Okay, bilangan bateri dan 5.1 lebih kecil ataupun lebih rendah. The angle of deflection in 5.1 because the first one here, first question I start with 5.1, so the second one also follow. okay, is smaller than 5.2. Okay, deflection pun lebih kecil dalam 5.1. The final position of copper rod is nearer okay. Final position of the copper rod is nearer to initial position in 5.1 than in 5.2. Okay. State a physical quantity that causes the rod to move. Force. Okay. Because one the word, okay, daya. D1, relate number of dry cell used and the magnitude of electric current. Okay, you can see from here, 5.1 smaller, number of dry cells smaller, angle of deflection smaller. Okay, smaller. Okay, so you can write the smaller the number of dry cell, the smaller the magnitude of current. Okay, the smaller number of dry cell, the smaller the magnitude of current. Okay, relate the magnitude of electric current and physical quantities stated in 5C. Okay, current and force. Okay, you can see for diagram 5.2, the copper rod is pushed further. When larger current flow, it pushed further means the force act also larger. Okay, so you can put in this way also can. The larger the magnitude of the electric current, the larger the force produced. Okay, ataupun the smaller the electric current, the smaller the force produced also can. We name the rule used to determine direction of movement of copper rod. We use Fleming left hand rule. Okay, because this one there is a power supply. The concept is force on current carrying automatic field, so we need to use Fleming's left hand rule. State another way that enable the rod displace further. Okay, you can displace it further if the combination of the magnetic field produced is stronger. Okay, so how to increase the strength of magnetic field? There are more than one method for this one. You can say maybe you can put as use stronger magnet. Okay, use smaller mass of rod. Use lighter one. So the force act will cause it to move further, or use lower resistance of rod. Okay, so either one, just put one because one mark only here. Use stronger magnet, we can see something like use bigger size of magnet, increase the number of magnet, also same meaning stronger magnet. Okay, number 6. Diagram shows design of circular wave generator machine being tested. A dipper is attached to vibrator that vibrates frequency 90 and 60. Dipper placed on the surface of water in the water reservoir. Okay, diagram shows surface of circular wave produced when dipper hits the surface of water in water reservoir. Okay, so you have question here, dipper. So this is the wavefront. Observe. For this one, higher or lower frequency, this is the wavefront produced. Okay. So firstly, before you answer this question, you must understand the terms mentioned here. Frequency. What is the meaning of frequency of 90 Hertz? What is this wavefront? Okay. Wavefront is a line that joins all points on the wave which are in phase. Okay. So we call it wavefront. Distance between two wavefront. This one is wavelength lambda. Okay, so for the frequency, let's say I put as f1 90 Hertz, I get this lambda 1. Okay, same thing here. Frequency up to 60 Hertz. Distance between two wavefront. This is lambda. Okay. Underline the correct answer to complete the sentence below. Wavefront is a line that connects all points that have same phase. Okay, for example, okay, there's you drop one stone on the surface of water, the water wave coming out. Okay. Okay, so all crest, this is crest, crest, crest. So we join or draw a line, we join the crest. We call it wavefront. So the crests are in phase. So you draw a line to join. Okay, to join all points which are in phase. So we call it wavefront. Okay, of the wave. Okay, underline satu saja. B1, compare depth of water in the reservoir. So you can see depth of water are same for both diagram. chapter are seen in 6.1 and 6.2. Compare frequency. So you can see the frequency for the first diagram is 90, second one is 60. So frequency of Dipper in 6.1 is higher or larger than in 6.2. Because 90, so kawan 90. Compare wavelength of circular wave. Wavelength of circular wave in 6.1 is shorter or dependent than in 6.2. Okay. Relate between frequency and wavelength. So you can see 6.1 higher. So ini ada mistake misal. 6.1 lah. Wavelength of circular wave 6.1 is shorter than in 6.2. So you can see wavelength shorter. Frequency higher. Wavelength shorter. Okay. Write down. The higher the frequency, of people, the shorter the wavelength. Okay. Explain what will happen if water depth in the water reservoir reduce if one preserve. How much? Wavelength decrease. Okay, because as depth increase, speed of wave decrease. Okay, this one also can be accepted as answer. If you want to elaborate more, you can relate between speed and wavelength. Okay. Okay, part D, diagram shows a surfer surfing wavelength 1.5, velocity 1.2, deep region. When surfer reaches shallower area, its velocity becomes 0.6. Okay, actually you can list out already for the deep region. So you have V1 equals to 1.2, lambda 1, 1.5 meter. Okay. Okay, for the shallow region, speed 2, V2 0.6, and lambda 2 don't have yet. Okay. Calculate wavelength in shallower region. From the formula V equals to F lambda, frequency is constant, V directly proportional to wavelength, thus we get V1 over lambda 1 equals to constant. So when this happens, V1 over lambda 1 equals to V2 over lambda 2. Okay, so you can assume V1 lambda 1 for deep region, V2 lambda 2 for shallower region. Okay, for V1, okay, 1.2 divided by 1.5 equals to 0.6 divided by lambda 2. So you calculate for lambda 2, you will get 0.75 meter second negative 1. Sorry, this is not speed, this is meter. Be careful, minute. So the wavelength in shallower region 0.75 meter. The number 7 figure shows electrical circuit containing two 1.5 volt dry cell open switch state. Okay. What is meant by 1.5 volt that is level on a dry cell? Okay, the one that level means (1.5) because volt E over Q, joule per coulomb. Okay, 1.5 joule of electrical energy is used to transfer 1 coulomb of charge. In electric circuit. Okay. Joule per coulomb maksudnya ialah 1.5 joule transfer 1 unit of charge or 1 coulomb of charge in a complete circuit. Inilah perkataan. Means from the positive terminal to negative terminal complete circuit. In a complete circuit. Okay. So based on diagram, explain why there is difference in ammeter reading and voltmeter readings in the circuit. 3 marks. Okay, diagram 7.1a. If you look carefully, look again. Here, switch open. When there's no current flow, the bulb of course does not light up. But the voltmeter reading show the reading. You can see V equals to 3 volt here. So open circuit reading of the voltmeter actually represent EMF of the battery. So this one actually is EMF. Okay. Okay. And then when the switch is closed, you can see current flow. So the bulb lights up. Reading of the voltmeter is equals to reading of the voltmeter across the bulb. V equals to IR. Okay. You can see the value of V drop because some of the voltage is used to overcome internal resistance of the battery. Okay, 7.1e is an open circuit. No current flow. And the reading of the voltmeter is called electromagnetic force. EMF. Okay. Diagram 7.1b is a closed circuit. Reading of voltmeter is less than EMF. Okay, the voltage loss due to resistance of battery. Okay, so the difference between 7.1e and 7.1b. Yeah. Okay, so 7.1b closed circuit. So reading of voltmeter drop less than EMF. So the voltage loss is due to resistance of battery, or internal resistance. Okay, internal resistance. Okay. Diagram 7.2 shows a torchlight, filament bulb. Okay. So we have bulb P and bulb Q, bulb R. Okay, filament, tungsten, copper, filament wire, single coil or coil. So this one is same as concept of heating element. Okay, same thing. When it able to produce large amount of heat, the bulb will lights up brighter. Okay. So characteristic of three filament PQR, explain suitability, determine the bulb which can serve a brighter torchlight used at night. Give reason of your choice. Okay. Filament, of course, made of high resistivity material, so it's made of tungsten. You can put answer high resistance or higher resistivity. Okay, the filament wire, we need to increase its resistance, so use longer wire, meaning coil. Sudah digulungkan lagi, gulung lagi ya. Maksudnya coil filament. Okay, reason longer wire, higher resistance. Okay. Okay, based on your answer, determine most suitable bulb. This case is okay, tungsten and coil. Okay, tungsten, coil. So we have iron. Okay, number 8. Last one. Cross section of wing of aeroplane. As you can see, this one is aerofoil. Cross section of the plane wing. Ini ya, sayap kapal terbang, potong sekerat tengah. Okay, cross section. Name the physics principle involved. Bernoulli's principle. Okay, Bernoulli's principle. Diagram shows jet of mass 2000 flying at constant height. Calculate lift force acting on the jet. Okay, so if same height, okay, it travel at a constant height, so travel with a force forward. There is a drag. There is a lift force, and there is weight. If maintain constant height, meaning the vertical forces must be balanced. Okay, thus F equals to mg. Lift force equals to mg. So the mass is 2000. Okay. And then G is 9.81. Okay. And calculate for this one, you will get the answer as 19,610. Okay, based on following aspect, give suggestion on how jet in diagram can fly higher. It can fly higher if it able to take off at the same time at angle of attack. Okay, actually when the angle is correct, angle of attack, it will exert extra force to the lift force. So means before just have this lift force to lift up, but angle of attack will give more force. Okay, more force to lift up the plane. Okay, so angle of attack must be larger. Okay, larger angle of attack. Okay, so when larger angle of attack, it will produce larger leaf force. Means there is an addition to the leaf force. Okay, when the plane take off at angle of attack. The thrust is larger. Thrust larger means it will increase the net force, horizontal force, and then the airplane can travel at higher speed or speed up or accelerate. Okay. Larger net force to higher speed or accelerate faster from the wing. Okay. Larger thrust. Surface area of wing P equals to F over A. Okay, factor area. Thus, F equals to PA. If this one is leaf force, P is the difference in pressure multiplied with area. Means the leaf force will increase if area increase. So surface area is larger. Okay, increase the leaf force. Okay. Okay, so for section A, I have finished for section A, Pahang trial chapter 2. I will continue with section B in my next session. Okay, thank you for joining me. Bye.